Which that'll be fine. I'll probably adjust that. It's not what I'm used to, but that's okay. So, and I'll stop switching to that. Now, still, that's fine. Access back. So, good. Sounds good.
Yes. Yes.
Okay.
That's fine. Yeah, we can have it right now.
And then we've normally been going by tech time. If that's okay with you, this one. So, hello, everyone. We'll get started in just a couple minutes. So welcome to the last academic seminar for this semester. Feel free to keep settling in, logging in. You may use your own personal Michigan Tech ID, or you can also use the library anonymous sign-in if you prefer. If you need help with reading that, I can come by and help with typing in digits for it. Also, we do have light refreshments available, so please feel free to help yourself. But if you do grab any of the coffee or the punch, please make sure to have a lid also on your cup. That's just one of the stipulations of us being in this space. And then I think we'll be starting in just a couple moments. So, and also I'll be passing around a sign-in sheet. If you would please just sign in for us. There are also name tags distributed. You're welcome to fill one out, although it's not obligatory by any means.
I can't help myself.
Okay, you're welcome to help yourself too at any point.
Thank you. Shall we begin?
Sure. Would you like a formal introduction?
It's up to you.
I leave it. It's your choice. Your seminar.
Okay, welcome everyone. I'm Mark Ockenbach. I'm the chair of the Department of Mathematical Sciences, and Jacob is a member of my department, actually taking a class from me. So when he asked me if I would give this seminar, I couldn't figure out any way to say no. So here I am. As you probably know, if you signed up in advance, I asked Jacob to distribute a little survey as to what kind of level of MATLAB you were interested in. Unfortunately, I gave 3 options and they were almost equally chosen, so it didn't really provide me with a lot of guidance as to what I might cover. So I decided I would start with pretty basic stuff, and we can go through it quickly if it seems too easy, or we can slow down at any point. I do hope you'll ask questions, because I'd like to not talk the whole 2 hours on my own. So anytime you have a question, feel free to ask. I'm going to follow this outline. There are 7 or 8 exercises that we'll stop, and I'll ask you to do those exercises. And I'll be happy to help you if you need help with any of those things. And if if after 20 minutes you think I'm boring you because it's way too easy, just tell me and I can speed up, and we can always do harder stuff if that's what you need. So just try to let me know. Is everyone logged into the computer now? So I hope you'll follow along and try things as I'm showing you. So I'm going to begin by starting MATLAB. I really like the MATLAB software. I'm a big fan, but it does irritate me that they issue so many updates. I'm always a year or 2 behind because I can't stand to keep reinstalling MATLAB time after time. So I'm actually using the 2016 release. I did go to the lab today and look at the 2018 release, and it looked pretty much the same to me, so I don't think you will see anything different than what I'm showing you here on the screen. All right, so I want to start by introducing the Matlab Desktop, which is what you're looking at. The important part is the command window, which is right here in the middle. This is where you would actually type something. So if you are just eager to know what 2 + 2 is, you can type 2 + 2 and find out that it's 4. You can do more complicated calculations. And one of the ways to think about MATLAB is it's a really good interactive calculator. If you want to do calculations, you can do them here in MATLAB. You can find out what e to the 20th power is. That's going to be a big number. You can find out the sign of 4. Of course, that's the sign of 4 radians. So for instance, if I put in pi radians, I get 0. Well, I don't actually get 0, right? The sign of pi is 0. Maybe this is the first thing to learn about MATLAB, is that it works by default in floating point arithmetic, finite precision arithmetic. So you will often see results that ought to be 0, and you don't quite see 0. You see a very small number. Now, you should learn how to interpret that format if you don't know already. This is an old-fashioned version of scientific notation. So this is 1.2246 times 10 to the negative 16, which is obviously a very small number. That is 0 that didn't quite get calculated as 0. Now, a lot of times you'll be doing calculations, you want to save them and save the result and use it for some other purpose. So you might want to assign a variable. So now I have a variable called s. The command whos is very useful. That will list for you all of the variables that are defined in your workspace. Now, MATLAB also has a little window over here, the Workspace Window, that is always showing you the variables that are defined and their values if the values are not too big to display. I mean, if the thing is a matrix, it's not going to display all the entries in the matrix. And I guess for some reason, the whole window is not being displayed here. It's probably a font problem on my computer. I'm not sure why, but that's okay because I'm going to minimize that workspace here pretty soon anyway. So you can assign variables to use later. I could, for instance, ask the question, is that number s that I computed, which is supposed to be the square root of 2, is it really the square root of 2? Is s squared equal to 2? And here's another example of what I was saying, finite precision arithmetic. S squared is almost exactly 2, but not quite. It's off by a little bit. So the first exercise is really trivial. but I would like you to find the larger root of this quadratic equation. And I would prefer that you do it by actually defining A, B, and C, and then expressing the quadratic formula in terms of the variables, if that makes sense. So go ahead and try to work that out, and then I will show you my solution. So in my quadratic here, A is 2, B is 3, C is -7, and the solution is negative B plus square root of B squared minus 4 times A times C, all divided by 2 times A. So that's what you should have gotten for the largest root. Of course, there's a plus or minus in the quadratic formula, but I ask you for the largest root. And then if we wanted to check that, I can type in ax squared plus bx plus c. And again, I get something that is very close to 0, not exactly equal to 0. Now, it's nice to learn how to use MATLAB in not only a correct way, but also in kind of a clean and efficient way. It's really annoying to me that I can't see my work. You know, I define A and define B and define C, and they've already scrolled up past. There are various ways that you can customize what you're looking at. One of the things that I like to do is type in format compact. Now if I type in A equals 2, you see the blank lines are not appearing? By default, in the default format, I type in a command, and there's a blank line, and A equals a blank line, and the output, and a blank line, which I find really annoying, because you can't see very much of the work that you're doing. So I like to use format compact, like so. Also, by default, I prefer to use what's called format short E, so that, for instance, like X, every number will be displayed in scientific notation. So this one, we didn't really need the X line, of course, because it's between 1 and 10. But I find it's easier just to have that consistent output. So I prefer always use format compact, always use format short E. Although occasionally I might want to see more output, so I can use format long E. And then I see essentially all of the digits in the answer. Now, of course, I can't quite say that because MATLAB, like all modern computers, would be working in binary arithmetic. So it has to convert to decimal display, and so this is not exactly all of, you know, the whole number, but it essentially is. Now, one of the consequences of being my age is I grew up on computers before the point-and-click era. So I personally like to type all my commands whenever possible, and I always find it a little annoying when I have to reach for the mouse. But you younger people may not be that way, so you may prefer to do things from menus and pointing and clicking. So you can go to the preferences here under environment, go to preferences, and there are approximately 1 million different kinds of preferences you can set. but the most important ones are on this command window preference. And here you can choose the numeric format. You know, so instead of typing format short E or long E, you can go to here and choose long E or choose short E. The opposite of format compact is format loose. So you can go and choose format loose if you prefer. Okay. And you can see there are quite a number of other preferences that you can choose off of that window. Okay. Now, you know, as I was saying, in terms of using MATLAB in kind of a clean and effective way, it was a little bit annoying to type in all those different values on different commands. If I want, I can assign all the variables on one line and just separate commands by a comma. So you can put multiple commands on a single line if you prefer. And then on work like this, you may not wish to see the output. It's really just echoing the values that you put in. Any command that is ended with a semicolon, that has the effect of suppressing the output. It doesn't echo the value. So you may want to do that frequently as well. Okay, any questions about any of that? MATLAB has an extensive help system, which I use a lot because I don't always remember everything. Now, I probably do remember what the sign function is called. It's called SIN. But if I ever forgot, I can type help and then the name of the MATLAB command, and I will get some information about it. This is a very simple command. It's just the sign function, so it's the sign of the argument in radians. At the bottom, it will always tell you the names of some other commands that you might want to check out. So here, a sign, you might be able to guess what that is. If not, you can look it up, or sign D. You might have guessed that a sign is the arc sign or the inverse sign. Sign D, you might not guess. That's the sign in degrees. So if for some reason you were working only in degrees and you didn't want to have to do the conversion between radians and degrees yourself, you can use the sign D command. That takes input in degrees. Once again, you know, I'm old-fashioned and like to type my commands, but if you prefer to use the browser, the desktop, you can go up here and type the name of what you're looking for, and the MATLAB Help Center will open, and here it gives me a list of these things. And so there is the same help. You see it's a little more verbose because it's not being displayed in the command window. And complete with examples and so forth. And then at the bottom, other commands that you might want to look at. Okay. At the end of the session, I will show you how to write your own MATLAB commands and even how to add them to the help system so that you can get help on your own commands. That's a very useful feature. Lastly, in this first part, I wanted to talk about customizing the desktop. Now, personally, I don't like to see this workspace window. I believe it's taking up unnecessary space that's better used otherwise, so I prefer to close it. So I go to this little arrow here, lots of choices, and I just close it, and then I get a bigger command window, which I like because I can see more output. I'll talk about this current folder window later. It's listing the files in the folder that I'm working in. It may not be clear what that means, the folder that I'm working in, the working directory, but I will talk about that later when we talk a little bit about programming in MATLAB. But for now, I would like to get rid of that because it's just taking up space. I can go up here to this environment option and choose layout and sort of do this automatically. If I choose the default layout, it goes back to where we started. Well, not quite, I'm not sure why. But I have the current folder in the workspace windows. My favorite is command window only, so I can go there. Let me show you another feature of the command window. Earlier, I defined S to be the square root of 2. Now, if I wanted to maybe compute the square root of 3, and I didn't want to type so much, I can use the up arrow. What I just did was to push the up arrow, and then it recalls the most recent command that starts with the same letter or letters. Okay, so I could do this, and then just change the 2 to a 3, and then I save myself typing. That command wasn't very long, so it wasn't a big deal. But on lengthy commands, you could imagine that might be a real advantage to be able to recall the commands. Now, personally, I love the command recall feature, but I don't like the pop-up window. So I like to go to this layout here and go to command history and say closed. So now if I type s equals, I can recall all the previous commands that started with s. But I don't see that pop-up window, which I find annoying. You may like it because from the pop-up window, you can go and choose an earlier command if you prefer. I just like to scroll through the earlier commands, personally. So the point is, you can customize the desktop in a lot of ways so that you're comfortable with how it works. You don't have to do it the same way I do, but I think that's a really nice feature about that. All right. We're 1/8 of the way done. Any questions? Yes.
So when you sign the, does it take angles in areas for every function or just
that particular function? So, if I type sine d of 180, I got 0. That's the same mathematically as sine of pi. You notice there's something a little bit different because for sine of pi, I only almost get 0. And for sine d of 180, I get exactly 0.
So what if I want to put everything out of?
Well, I mean, you're just using the trig functions, and you can use sine d, cosine d, tan d, and work all in degrees in that sense. Yeah. Other questions? Okay, let's talk just a little bit about linear algebra. So we're on part 2 on my outline here. Matlab, if you want to know where the name came from, it was created by a mathematician named Cleve Moeller, and he created it to do numerical linear algebra. And he created it as a tool for his students, and the original name was Matrix Laboratory, so that got shortened to Matlab. So Matlab is sort of matrix vector oriented. That's how it was begun. So we can create vectors in Matlab. Like here's the vector 1, 2, 3. That is a row vector. If I want it to be a column vector, I separate the components with semicolons instead of with spaces. Commas are equivalent to spaces. So if you prefer, you can separate with commas. If I want to enter a matrix, I separate the rows with semicolons. It might be a little confusing to enter that matrix the way I just did because visually the rows are not separated. So you have the option of hitting a return for the new rows. And then visually that's a little bit easier possibly to enter. There are a number of commands for creating common vectors. The simplest one is to use the colon operator. 1:5 creates a row vector where the first component is 1 and the last component is 5, and the components go up by the integer 1. Okay, so there you go. By the way, I forgot to mention this before. If I do a calculation and I don't assign the output to a variable, Matlab automatically assigns it to the default variable ANS, short for answer. So there's almost always this default variable ANS hanging around. It's the result of the last calculation you did that you didn't assign to a variable. And speaking of variables, if you're working for a while and you want to know what variables you've defined, the command whos will list all of your variables, and it will tell you something about them. To Matlab, everything is a matrix by default. So, A is a 3x3 matrix. This little a was just a number that I entered. It was a scalar. But to MATLAB, everything being a matrix, a scalar is a 1-by-1 matrix. And then I've got a couple of vectors here, 1-by-5 and 1-by-3. There is also the command who, without the S. We'll just list the variables, but it doesn't tell you anything about them. I never use who myself because I always want to see that extra information. But you can use that if you prefer. Okay, so the colon operator is useful. You can also use it with a step size. 2:2:10 means go from 2 to 10 in steps of 2. A similar command is the Linspace command. Now, Linspace creates what MATLAB would call a linearly spaced vector, beginning, say, with 1, ending with 3, and let's say with 101 components. So those of you who do numerical calculations, this is a great command for creating a grid. I just created an evenly spaced grid with endpoints 1 and 3 and 100 subintervals, or 101 grid points. In a little while, we'll use that sort of command for graphic.
Could you show that command again?
Yes. Linspace, short for linearly spaced. Now, a lot of times in linear algebra, we like to work with column vectors instead of row vectors. This is always one thing that puzzled me about the way MATLAB was designed, because it was designed by mathematicians, and we mathematicians almost all like to use column vectors instead of row vectors. But for whatever reason, the default for many of these commands is a row vector. In MATLAB, you take the transpose with the prime or the single apostrophe operator. So if I do this constantly when I'm creating my grid, I want to store it as a column vector, so I put a prime at the end almost always, and then I get that same vector except oriented as a column vector. Sometimes you want a constant vector. The ones command is very useful. That created a 10-by-1 matrix, which is a 10 vector, where all of the components are 1. Of course, if I wanted all the components to be 3, I just multiply that by 3. That works for matrices as well. So here's a matrix with 4 rows and 3 columns. Every component is 1. The zeros command is similar. Here's the 0 matrix with 2 rows and 3 columns. I can enter a couple of vectors. Okay, those are both column vectors. And then I might want to take the dot product. There is a command called dot to compute the dot product of 2 vectors. You know what that means? It means you multiply the corresponding components and then add up all the products. I actually didn't know until today. Later I'm going to show you how to time commands in MATLAB and how to do things efficiently. I didn't actually know until today when I was doing some experiments that dot is kind of slow. So the other way mathematically to take the dot product of 2 column vectors is to think of them as matrices and do a matrix multiplication. X transpose Y. Okay, so that would give you your first column vector turned into a row vector times the column vector, and you do a matrix multiplication. That's actually more efficient. So the other way I could do this is do X prime times Y. I get the same answer. Any questions so far? I showed you how to enter a matrix entry by entry. Sometimes you might want to create a random matrix, that is a matrix with random entries. You might do this for testing algorithms or just for playing around. This rand n command creates a matrix of the size that you give it. the N stands for normally distributed. So the numbers that appear here are drawn from a standard normal distribution, the bell-shaped curve sort of thing. If you prefer, there's simply rand. Those numbers are drawn from a uniform distribution between 0 and 1. You can do vectors the same way. There's a column vector with 3 components and random entries. Okay, operating on matrices in MATLAB is just as convenient as operating on numbers. So I had 2 3x3 matrices. I can add them in the obvious way. Of course, I can subtract them. I can multiply them because their sizes are compatible. I could not add a plus x. Now, before I try to do that, let's just remember, a is 3x3, x is 3x1. It would not make any sense to add a plus x. I have no idea what just happened. A plus x should not be defined. Somebody will have to explain that to me sometime. So,
Not defined ANX.
well, a is 3x3, x is 3x1.
Oh.
A plus x should not be defined.
Oh, okay.
That's a puzzle to me. But there's an example. I tried to add a 3x3 and a 3x2 matrix, and I get the error message that I expected to see before. Okay?
He's probably adding that all the columns and
Probably. I mean, that's the only thing I could guess. I don't know why it does that, though. I've never seen that feature before. But you're probably right. I mean, MATLAB does have the feature that you can add a scalar to a matrix, and that does mean add the scalar to every component. So that I was aware of. I could multiply A times C. Now, you remember how matrix multiplication works. If you're multiplying an M by N matrix times an N by P matrix, that works, and the output is M by P. But these two dimensions have to be equal for the product to be defined. So I just computed A times, well, we're about to compute A times C. That was a 3x3 times a 3x2, and I get a 3x2. But if I try to compute C times A, I get an error message because there I'm trying to multiply 3x2 times 3x3, and the inner dimensions do not agree. Okay, and then let's take a 3x1 vector. So now A is a 3x3 matrix. B is a 3x1 vector. It would make sense to try to solve AX equals B. Okay, that's how you commonly represent a system of linear equations as a coefficient matrix times a vector equal to another vector. And the solution of this, assuming A is a non-singular matrix, is X equals A inverse B. MATLAB Muller created this idea that the backslash operator would represent that kind of a quote-unquote division. You know, division mathematically is defined to be multiplication by the multiplicative inverse. So this is a kind of division. We're multiplying by the inverse of the matrix. And so that's the notation that MATLAB uses. There you go. Is that indeed the solution? Well, we could take A times X minus B. That should be 0 if we solve the system correctly. And you can see it is virtually 0, up to round off error. I could also test that if I wanted to by computing the norm of the vector. And I get a very small norm for that residual. Okay, so exercise 2. I gave you a little linear system to solve. of the form A transpose AX equals A transpose B. And I told you what A and B are. So why don't you enter those quantities and see if you can solve the system. I did forget to tell you that pi in MATLAB is a built-in variable, spelled out EI. So you don't have to type in the numeric value of pi, it's already known. Okay, so if you entered the quantities correctly, here's the calculation you should do. A transpose A divided into A transpose B, like so. What kind of mistakes could you make? Well, you might forget the parentheses. You got the same thing. Because it's just computing from left to right. So that's right. In this case, the parentheses are not necessary. How good is that solution? Well, let's see. A transpose A times X minus A transpose B. Correct up to round off error. How close is AX to B? Not all that close. Okay, if I wanted to, as I asked you to do, find the norm, the relative residual, I can do that kind of calculation. And that tells me how close AX is to B. Now, suppose, and by the way, if you've been building up variables and you want to get rid of them all and kind of start over again, you can use the clear command. You'll see now I have no variables. Also, the CLC, that's for clearing the command window, clearing the display in the command window. That's often useful. So, let's look at this simple 3x3 matrix. As it turns out, that matrix is singular. If I compute the determinant, I get essentially 0. So the question is, now, what happens if I try to solve a system with a singular matrix? Well, Matlab is working in floating point arithmetic, finite precision arithmetic. It doesn't really know if that matrix is singular or not, but it knows that there's something wrong. And it gives you a message that says the matrix is close to singular or badly scaled. So that message should warn you that probably your matrix is singular and the calculation you just tried to do is not well defined. But it does produce whatever numbers come out of the algorithm, even though they may not be meaningful. Now, I'm mostly talking about MATLAB today and not about math or numerical analysis, but I did just want to point this out. So let me clear the variables and the window and see if you can follow this calculation. I create a 100 by 99 matrix, and then I assign a 100th column. So I start out with only 99 columns, and I'm going to assign a 100th column to be the original matrix times a random vector. Okay. So now the question arises, how good are you at linear algebra and how well do you know the math? That last column of the matrix that I just created is a linear combination of the first 99 columns. What does that tell me about the matrix? And if you're coming here from math sciences, you better be able to answer my question or you're going to be in trouble. So I heard somebody say something. It's singular because I mean, that's the columns of a non-singular matrix have to be linearly independent. If you've got one column which is a linear combination of the rest, those columns are linearly dependent and the matrix is singular. Now in elementary linear algebra, you learn to check for a matrix being singular by checking the determinant. If the determinant is 0, the matrix is singular. If the determinant is non-zero, the matrix is non-singular. What do we get if we compute the determinant of this matrix? Wow, that number is about as non-zero as you could expect. Okay? Does that mean the matrix is non-singular? The answer is no. And like I said, I'm not mostly doing math today, I'm mostly doing MATLAB, but the determinant is actually a terrible way of testing for a matrix to be non-singular in finite precision arithmetic. So don't ever do that. Don't ever use the determinant to figure out if your matrix is non-singular or not. If we ask MATLAB what the rank of the matrix is, it can tell me that the rank is only 99, and since the rank is less than 100, it is a singular matrix. So MATLAB is smart enough to figure that out, but not if you ask it a stupid question, okay? And asking for the determinant of a 100 by 100 floating point matrix is a stupid question, okay? I'm ready to go on to graphics. Any questions before I go on to graphics?
I have a question. So the top command line, you're finding a matrix that's 100 rows?
Yep, 100 rows and 99 columns. And then this is something I probably should have pointed out explicitly. Matlab allows you to resize matrices and vectors. So I've got a 100 by 99 matrix, but then I want to add a 100th column to it. And Matlab allows me to do that. So the other columns remain the same, and I've tacked on a 100th column. Now, what is that 100th column? It's the matrix A, this one, the 100 by 99 matrix, times a random vector with 99 components. So I do this matrix vector product, I stick that in the matrix as the 100th column, and that's how I created a singular matrix. Good question. Other questions? Okay, let's talk about graphics. I like Matlab Graphics because they're very simple, especially when we're talking about curves. I know exactly what Matlab is doing. So let's suppose that I wanted to graph the sine from 0 to 2 pi. So first of all, this Linspace command I told you before is very useful. That creates a vector with 101 evenly spaced points, starting at 0 and ending in 2 pi. I'm always in the habit of choosing 101 because I'm always thinking about grids in the numerical sense. And I just divided the interval from 0 to 2 pi into 100 small intervals of equal length. There are 101 points because of the extra endpoint. So I just do that without thinking. And let's say y is the sine of t. Now I'm going to talk more about this in a minute, but functions defined in Matlab are vectorized by default. Vectorized means that if you apply the function to a vector, it applies it to each component of the vector and spits out a vector of the same size. So mathematically, this would not really make sense. What's the sign of a vector? That's not defined mathematically. But in Matlab, that is defined to be the vector you get by applying the sign function to every component of the input vector. Okay? Now, if I ask Matlab to plot t versus y, it does something very simple. It just plots the points. I have now 101 t values, 101 y values. It thinks of those two column vectors as defining 101 points in the plane. T1, Y1, T2, Y2, T3, Y3, and so forth. It just plots those points and connects them with short line segments. Now I have enough points in my grid that what I get looks like an actual curve. What it actually is a polygonal curve or a piecewise linear function. I can show you that by doing it again. But now I'm going to change this so that instead of 100 subintervals, I'm only going to do 10. Now, you can see that I don't get a smooth curve if I use too coarse of a grid. So again, I kind of like that feature of Matlab that I know exactly what it's doing when I ask it to plot a curve. If you use Mathematica or something, it's more intelligent in a way. It makes decisions for you of how many points it's going to plot and so forth. Matlab doesn't do that, which has its advantages and disadvantages. But I like knowing what's going on. Now, by the way, you notice when I bring the command window back to the front, and if I change something, I don't see the graphic automatically. So I am in the habit of doing this. I give the figure command followed by my graphics command because the figure command will bring the figure to the front. You don't have to do that, but I find it convenient. Now, what did I just do? I gave an extra option here that told Matlab how I wanted it to plot the points. And I wanted to plot them just as points. Don't connect them with lines. Now, the default is the dash, which means a straight line. There are other options. If I put a dash dash, that means a dashed line. If I put a colon, that means a dotted line. I can give it a color if I want. I want it to be red. A few other options. The O plots the points as little circles. I'm sorry? Yeah. The O means little circles. Now, of course, I'm going very quickly. Nobody can remember all this stuff. But just remember At any time, you can type help plot. Unlike the sign command, plot is rather complicated. It has lots of options. So the help command will tell you all this stuff. And there, for instance, if you want to know what are all the colors you can use, there they are. I only showed you red. Blue is the default, but there are half a dozen other colors you can use. If you want to know the line types you can use, it's all here. So you always get help from Matlab if you forget something. Now, if I want to plot two functions on the same figure, I do it like that. Notice what I did. I have to give the x coordinate, y coordinate, x coordinate, y coordinate like that. If I want to use different, now notice MATLAB did use different colors to distinguish by default. If that's not what I want to do, I can add this extra. Maybe I want to be do the black dashed line, and then here I want to do a green dotted line. Okay, sorry. That wasn't a very good choice because you can hardly see the green one, but you don't always know that until you try it. So
if you do multiple plots on one line, let's say you want to do 5 of them, you just do the same thing where you define the arguments.
Yes.
So T, Y,
Yep.
you know, whatever one you define, you can do it so it's an arbitrary amount that you could add.
Yeah, I mean, I don't know if there's any limit or not, but I've never reached it. I mean, you can certainly do 5.
Okay.
Yeah. There's 3. Not very interesting because each of the x grows too quickly. We are not restricted to plotting functions. So if I did 0 to pi, let's say 361 points, I could plot cosine of t versus sine of t, and you know what I'll get, right? I will get a circle. Except I didn't quite get a circle because MATLAB uses a certain aspect ratio by default. And that default wasn't a good choice for that because my circle doesn't quite look round. There is an axis command which you can use for a lot of different purposes. So one thing I can do is give it the range, the window that I want to see. Now this command expanded the window, but I can also ask it to, I think equal is what I want, sorry, make the scale on the x and y axes to be the same. That's what equal means. So now my circle looks round. Once again, I won't go through all the options in Axis, but if you want to know what you can do with Axis, there are lots of options. One thing you can do is say off, and then I only get the curve. Okay. Questions before I go on? You can do a lot to label your curve, so let's go back to this one, but I don't want that exponential. Let's go back to this, and let's change that so I can see it. Okay. How might you want to annotate this? Well, you might want to say that horizontal variable is t. So the x label command puts the text on the horizontal axis. On the vertical axis, I might want to put f of t, for instance. You might not be able to read that, so there are lots of options. I can make the font size bigger, like that. I might want to put a title on my graph. That goes at the top. Again, I can change the font size on that if I want. And then the legend command adds this legend. Okay, so it tells you that the dashed curve is, well, it just puts whatever text I typed in. I put y equals f of t, and the green curve is y equals g of t. You can put more extensive text in there if you want to. Matlab will try to put this little box where it doesn't clash too much with your graph. Like if all the action is up here, the curves are up here, it might put the box down here. You can also tell it where to put the box. You can look up the do help legend if you want to get more information about that. Okay? One more thing I need to tell you. Suppose that I want to graph a function that looks like this. 1 over 1 plus t squared. Okay, so first I'm going to change t so it's, so let's say -4 to 4. And suppose I said y equals 1 divided by 1 plus t squared. Okay, I got an error because what I tried to do wasn't very sensible. I took a vector and I asked Matlab to square it. And then if that had worked, I would be asking Matlab to divide by a vector. Okay, that's not really what I want to do. Squaring a vector doesn't make sense. However, squaring the components of a vector does make sense. And Matlab has a different operator for doing component-wise arithmetic. Okay, so instead of the caret, which means square a matrix, I use the dot caret, which means square the components of the matrix or vector. Similarly, here I want to divide. I said I want to divide 1 by this vector. That's not what I want to do. I want to divide 1 by every component of the vector. And that's what the dot slash operator does. So those are called component-wise arithmetic operators. The 3 you need to, and so let me just show you the output here. There's my function. This one. Okay. The 3 component-wise operators you need to know are dot times, dot slash, and dot caret. If you think about it, plus and minus are already defined component-wise. You don't need a dot plus operator because that's what plus means, do it component-wise. Okay, so now I've told you enough. You can do exercise 3, which is to graph this slightly complicated function on the interval from -2 pi to 2 pi. Use a fine enough grid that it looks like a curve, not like a polygonal line.
Could you move the plot a little bit to the right so I can see the text that you're in?
Yes. So here's my solution to the problem. I create that linearly spaced vector, and then I am careful to vectorize my calculation. I need sine of x squared, so I use the dot caret. I have to multiply these two vectors, so I use the dot star. Now notice cosine is vectorized as a built-in MATLAB function, so there's nothing extra I have to do there, and so is the exponential function. So that part is automatically vectorized. Of course, like I was saying before, the subtraction is vectorized by definition, but here I'm doing a vectorized multiplication. Here's what my graph looks like. I might not like the fact that for some reason, it went out from -8 to 8. So again, I could say the axis would be from -2 pi to 2 pi, and it would go from, I don't know, let's give from -pi to pi, for instance. And then it looks just a little bit different because I've changed the window. Any questions about that? Ready to go on? This is kind of a whirlwind tour. I hope this is kind of what you were looking for. This session is recorded, so you'll be able to go back and review. And if you look at right now, maybe look at the last page of your handout. There's a URL for a collection of 11 YouTube videos that I created for a course I taught that goes through all of this stuff and more. It's about 2 hours total, but it introduces all sorts of things about MATLAB and programming in MATLAB and graphics and so forth. So if you want more of this, you can check out those videos. Okay. Let's talk about other kinds of calculations. Let's suppose I want to compute the integral from 0 to 3, let's say, of sine of t squared dt. Now there is a command in MATLAB called integral, which does numerical integration. But I have to know how to define a function so that I can pass the function to the integral command. How many of you know Mathematica? Anybody know Mathematica? Just a few of you. Okay, so I won't talk about Mathematica. Every system like this, though, has to have some kind of syntax for saying, I'm defining a function, and this is the input variable, and then this is the formula that defines the function. So Matlab syntax looks a little funny the first time you see it, but it uses the @ command, followed by the input variable, and then followed by the formula that defines the function. Okay? So I just said f is a function with one input variable. The input variable is named t, and given the input t, the output is sine of t squared. And notice I did vectorize it because I knew I was going to want to use the vectorization. So if now, for instance, I want to plot this from 0 to 5, let's say. Oops. X. There's what the function looks like. What else can I do with it? Well, I could just evaluate it at a point. I want to know what f of 2.5 is. And I could pass it to the built-in command integral. So if I want to integrate f from 0 to 1, I guess I wrote 3 on the board. Integrate f from 0 to 3. There's the value. Integral is relatively complicated. It has a lot of options. It can do complex integration as well. It uses a default tolerance. This is numerical integration. In other words, it's approximating the integral, not computing it exactly. And so there are tolerances. And it tries to compute the integral so that the error is bounded like this. So it might sometimes happen that the default tolerance is not tight enough, and you might want to change it to a smaller tolerance to get a more accurate answer. So that ability is there if you want to use it. Yeah.
Is it doing the integral of the function f between the bounds are 0 and 3?
Yep. That's right.
Can you show function?
Yes. There's the function definition.
So T is the dependent variable over there, and after that the function.
T is called the independent variable. It's the input variable.
Yeah.
And what follows here is the formula that defines the output.
I'm thinking if we have a more complex equation over there, the functions, Matlab expression added together, should all they be in
It doesn't. They don't have to be because no, because Matlab just parses off this part, and it says whatever follows is the definition of the function.
So if it is plus cosine, the same expression over there, it just.
You don't need the extra parentheses. You can put them in. It wouldn't hurt anything, but they're not required.
So
Yes. Yeah. I'm not going to show you any multivariable math today, but if you wanted, you could say sine of x times. So there's a function of two variables, and you can evaluate it like that. Yeah. So that was an example of what you were asking me about. Did I need to put all of this in parentheses? No, I could have, but it's not necessary. Now let's go back to my original F, which was this one. I still have the graph here. Let's suppose that I wanted to compute this 0. You see where, of course, f of 0 is 0, but then there's another point here, or actually several points where f of t is equal to 0. Let's suppose I want to compute that solution to the equation f of t equals 0. First of all, I might want to get an estimate of where that is. And sometimes adding a grid to the graph is useful. I just type the command grid, and it puts this grid here. And then I can see it crosses 0 right around, I don't know, 1.7, 1.8, something like that. I think it's actually the square root of pi, but let's pretend like we don't know that. Okay. There is a command called f0, which will approximate a 0 or a root of a function. Again, a very complicated command. The simple version of it, though, is I just say I want a 0 of this function that's close to this starting point. Okay, because it's for nonlinear root finding, you have to give it a guess as to the value you're looking for. So from looking at this graph, I would say my guess is 1.7. So let's try f0, f, comma 1.7. And I find that the answer is that. I think that's the square root of pi. Yep, it was supposed to be. If I gave it a different starting point, like here, there's a 0 very close to 2.5. So let's do f0, f 2.5. It finds that 0. and so forth. Okay, so now I gave you your first hard exercise. We've just been playing around up until now, but this one's a little more challenging. Exercise 4, take the function from exercise 3, call that f. I want you to find the area under the graph of y equals f of x from a to b, where a and b are the two smallest zeros of that function f. So it's kind of a multi-step problem for you to do here. Okay, let me show you a solution to this problem. Now it's getting to be obvious that I won't get all the way through my outline. So I'm gonna skip a little bit here and introduce scripts in MATLAB, which are number 7 on my outline. This is a multi-step problem, and probably I would like to put my solution in a file so that I don't have to remember the commands I use. You know, maybe next week I might want to look back and see exactly what commands I used to solve this problem, so it'd be nice to have them in a file. Also, even while I'm solving the problem, I'll probably make some mistakes and have to modify my commands, and it's kind of nice to have them in a file where I can execute them so I don't have to keep retyping them. So MATLAB has a built-in editor, which is quite convenient. If I go up here to the New button, choose a new script, the editor will pop up. Now, personally, I don't like everything crammed together here in one window. So the first thing I'm going to do is undock the editor so that it appears in a separate window and I've got more room to work.
What was the command for opening the editor?
I'll show you. I went here to New, clicked on that, and then chose a new script. You notice a shortcut on my Mac would be a Command N. Probably looks a little bit different on your workstation, but there's a shortcut for that. Okay, so here's my editor. The first thing I'm going to do is define that function. So hopefully I'll type it correctly. Okay, then I'm gonna graph it. Now, the great thing about, I've got to save it. So this is exercise, what was exercise 4? Okay. So the great thing about creating a script is, oops, let me just find my window. I can execute the script by just typing its name. So I called that script ex4.m. So I can just type ex4. And there it produced the plot that I asked for. Now, in the problem I gave you, you have to find the first 2 zeros. That'd be this 0 and this 0. The first one is close to 1, and the second one is close to 6. Okay, so the next thing I'm going to do in my file here is find those 2 zeros. I won't put the semicolon so I can see the output. Okay. Okay, and I believe that I did find those values correctly. F of A and F of B are both 0 or very darn close. So then the last step in my problem is to compute the integral. So there's the answer. That integral is about 2.9. How many people got that? Some of you did. Good. Now this MATLAB editor is very powerful. So first of all, I could have run my script just by going up here and clicking run. I'm not used to doing that because, again, I'm kind of old and old-fashioned. But you can just click that button to run it. More importantly, there is a debugger here that's built in. I will not have time to describe the debugger, but if you're writing serious programs in MATLAB, anytime you're doing serious programming, you're always making serious mistakes, at least that's my experience. And then you have to find your mistakes, which is called debugging. And, you know, computer programming has been around since what, the 40s or 50s, so that's 60 years or so. And in those 60 years, computer scientists have figured out it's really nice to have some automated aids for debugging. A debugger is a program that allows you to run your code step-by-step, examine the values of the variables at intermediate steps, or run it up to a breakpoint and stop there, or lots of different things. So MATLAB has a very nice built-in debugger. If you want to learn how to use it, if you're going to be doing serious programming in MATLAB, find my video on the debugger, and it will go through step by step and tell you the main features of the debugger. You'll find that very useful if you're doing a lot of programming. Okay, any questions about this exercise we just did? Yes?
Is there a way that when you're doing this, you can kind of make your file interactive where you can ask for inputs?
Yes.
Is it just learning the call for that?
I almost never do that kind of programming myself. Yeah, there is an input command, prompt for user input. So that's kind of a command that they've created to do that. There would be other ways of doing it where you use a write statement to write something to the screen, and then use a read statement to read it back. Input kind of combines those operations. Yeah. Other questions? Okay, I'm going to skip number 5. I'll come back to it if we have time. Let's go to number 6, some basic programming. By the way, if you don't want to see your editor around, you can just kill it. You don't want to see the window around, the graphics window. You can also exit, or the close command. Close is for closing graphics windows. Okay. All right. Let's suppose I want to compute a dot product. So maybe X is a random vector with 10 entries. Y is another random vector with 10 entries. Of course, I know how to compute the dot product like that. If I didn't know how to do that, I could say S equals 0 for I equals 1 to 10. S equals S plus X of I times Y of I, end. I get the same value. That's a for loop in MATLAB. It might have been maybe better if I had done it step by step like this. That's how a for loop operates. So a for loop is to execute a command or a collection of commands repeatedly a given number of times. So here I'm going to do it 10 times because I'm going to start with I equals 1 and go up to I equals 10. Each time this command executes, I has a different value. That's how a for loop works. Now, let's be a little more ambitious. Let's take n equal to 1,000,000, that's 10 to the 6th, and make x and y both have n components. And then let's do that command here, where I compute the dot product. So the first thing to notice is MATLAB's pretty fast. It just did that, 1 million, really 2 million operations, and you couldn't even see how long it took because it was so fast. But, we can always overwhelm the computer with enough data. So there you notice it took a while to create 2 vectors of length 100 million. And now if I do this calculation, it takes a little bit of time, still not very much. Sometimes when you're doing programming, you will want to time your code. So MATLAB provides these 2 commands called tick and talk. Okay, you issue tick first, then you do whatever calculations you want to do, you want to time, and then you issue talk, and it tells you how much time elapsed between the beginning and the end. So that took 0.6 seconds to compute that dot product. Now, interestingly, that took a lot less time, only about 1/10 of the time. In principle, Matlab has to be doing this inside of this command. Does anybody know why the second version was so much faster than the first version? I don't think it's parallelized. I mean, it could be because nowadays, even my laptop has multiple processors in it. That could be, but I doubt it. We have another guess? It's compiled versus interpreted code. That's the main issue. So when I issue this command, Matlab passes the data to a program, a subroutine that it has formerly written, and compiled into machine code. So that is code that the processor reads in its native, it's the native tongue of the processor, and it's really fast. When I issue this command, I have just typed out a loop which Matlab has to read and interpret and execute. And that code itself is not compiled, it's interpreted. Interpreted code is always a lot slower than compiled code. So one of the morals of the story is if you want to use Matlab efficiently, you always try to take advantage of built-in operations and commands, because then you'll be executing compiled code. Whenever you write loops and conditionals and so forth, that code has to be interpreted, and it is going to be slow. Well, you know, comparatively slow. It's still not very slow because, you know, what did I choose? 2 vectors of length 100 million, and I computed the dot product in 0.6 seconds. So that's not, you know, I wouldn't really say it's slow, but it is slow compared to the built-in Matlab command.
What's faster with the matrix multiplication compared to the?
Say again?
You said the matrix multiplication is faster than the dot product.
Well, I mean, it's not really that. It's that when I type out the code for the dot product, that code has to be interpreted and executed. When I use the built-in Matlab operation, the data just gets passed to a compiled subroutine that's in machine code, and it executes really quickly. Oh, previously, that's right. The dot command. Yeah, let me show you this. If I can type the code for commands, and there you see the code for the dot command. Now, certain commands, I have to think of one, like norm is a built-in function. I can't see the code. That's compiled code. That dot command, I didn't know this until today, but that is actually not a compiled command. It executes that Matlab code I just showed you here, and so it's interpreted and it's a little bit slow. Yeah, so we can see that here. There's the matrix multiplication. There's the dot command. The dot command is actually very slow, interestingly enough. So again, well, I mean, 2 things I should say. Matlab is a fantastic environment, but it's not really for production code. You know, if you're solving your engineering problem and there's a lot of data involved and you're going to be using it in the real world to do real work, you probably want to ultimately write that code in C or Fortran or something and have it compiled so it'll be very fast. Matlab is really not for that purpose, but it is a great research tool because it's a lot easier to use than writing everything from scratch in C or C++ or whatever. So I use it all the time. When you're using it and you want to use it as efficiently as possible, always try to use built-in compiled code instead of code that you write yourself, as much as you can. Okay, so I just wrote that script. It was called ex4. I wanted to mention the what command. What is like whose. Whose lists your variables. What lists your M files. There is this concept of the working directory or the current folder. This is the folder that MATLAB will look in for commands that are not MATLAB commands. In other words, commands that you write. It has to look for them somewhere. It looks in the current folder. Now, there are different ways to find the current folder. Print working directory, PWD. That will tell you what the current folder is. You can change directories. Oops, I didn't have a directory name now. Have to actually give it a valid name. Ah, I'm just leaving off the S, sorry. Users. There we go. Okay, so you can change to a different directory. And in this directory, I believe I have a lot of M files. Yeah. Quite a lot. Okay. What will also list your mat files? Those are data files. So if you store your variables, the extension is .mat, and what will list those files as well. If I went back to the default environment, the default layout, there is this current folder. Actually, I'm going to close that. Okay, sorry. Yeah, I use this so little, so I didn't know how to look. It lists, I have a bunch of subdirectories in that folder, and then it lists the M files that I have in that folder. As you can see, it's not all that useful because it's so packed together. But that's what that window is for. Okay. Any questions? Okay, so a script is a MATLAB file, an M file, that contains commands. When you type the name of the script, it executes just as if you had typed those commands one by one in the command window. I'm now going to explain what a MATLAB function is, a user-defined function. And it has a couple of different features. So if I ask for a new function, the MATLAB editor comes up, and it shows me the template for creating a function. So a function has input arguments, it has output arguments, it has a name. The keyword function tells MATLAB that this is a function file and not a script. A script does not have inputs and outputs. A function has inputs and outputs. So let's suppose, and I'll move on towards this exercise I gave you because I'm not sure we're going to have time to do it, have time for you to do it. So exercise 8, I ask you to write an M file that would implement this function. So let's suppose I want to implement that. I will call that function, I'm going to call it myFun. The output will be called f of x. The input will be x and a. I'm just going to kill this stuff so we don't have to look at it. I would first want to store it. I need to get back to the other directory. Okay. And I do need to remember to change directories back to where I was. I can use this menu to do that. All right. So I want to integrate sine of a times the square root of t from 0 to x squared. And that's the value of f of x. So fx is integral of what? Well, I have to have an f. Okay, so I've got to define my f. Does that make sense what this is supposed to do? I'm going to pass in the value of x in the parameter a, and I'm going to integrate that function. I made a little mistake here. This is what I called f. I should give that a different name. I'll call it g. Okay, so I define the integrand. That's the function I call g. And then I integrate g from 0 to x squared, and that's the value of f of x. Why is it called fx? Well, it's just because I decided to name the output variable fx. I could have named it anything. Now, some of you might be wondering, what about this parameter a? I didn't mention it here. And the answer to that is, when I define a function like this, if it involves any parameters, MATLAB will use whatever value that variable has in the workspace. So that what I wrote there is just fine. I'm going to pass in a value for a. That value will be known when this command executes, and that value will be used. So if I go to my command window now, make sure I'm in the right place. I am. So let's say I want to know what's the value of f when x is 1 and a is 2. Well, first of all, I made a mistake because the function was not called f. It was called myFun. There we go. I could assign that value to a variable if I wanted to. I could say b equals myFun of 1, 2. But notice if I just said, for instance, b equals myFun, I'm going to get an error. In the same way, if I just type like sine, I'm going to get an error. Because these are both functions that take inputs. And I cannot execute the function without the input or the inputs. So that is the basic idea of a MATLAB function. If I have something that's complicated enough that I can't define it with just one line of code using the @ operator, then I can put it in a file and create a function that way. That idea makes sense?
One more time.
So if I have a relatively simple function, like let's say my function is just f of x equals, I don't know, 3 sine of pi x. That function is simple enough, I can define it in the MATLAB command window like this. And there it is. No need to write an M file. But if I have a function that has a more complicated definition, and I cannot define it using just a formula, that's when I would want to use an M file, a MATLAB function stored in an M file. What sort of function would what be?
Oh, so we could put
Well, like this is an example.
Oh, okay.
Yeah. It would not be impossible to do that in one line of code, but it would be kind of complicated. And of course, you can imagine a function that requires many lines of code just to compute it. Maybe you can't, but I mean, such functions certainly exist.
Okay, so for this one, you could just like the function inside the function, but it might be complicated.
Right. Right. Now, if we look at the files in the directory directly, well, this is my presentation. That's what you're looking at on your paper. But here's example exercise 4. Here's the function file that I just wrote. MATLAB refers to these as M files. ex4.m is a script. myfun.m is a function. Okay, so they're both M files, but there are script M files and there are function M files. And this is worth emphasizing, and it's a little bit subtle. The commands in a script are executed just as if you had typed them in the command window. Any variables that are defined in the command window can be used inside the script. So let me give you an example of that. Let me create a new script. And let me say x equals rand n of n comma 1, y equals rand n of n comma 1, tick, s equals x prime times y, pi, display s. I will call that example. Now, if you're used to doing programming, you should look at that code and say, wait a second, you're using the variable n, which you have not defined. But I might want to do that on purpose. This is a script. It can refer to any variable that's defined in the Matlab workspace, in the command window, that is. So I could now go to the command window and type maybe n equals 1,000,000. And then run the example. That didn't take very long. I could do n equals 10,000,000. That takes a bit longer. I could do n equals 100,000,000. That now takes an appreciable amount of time. In a function file, now by the way, in the editor, MATLAB could have many files open. So I can click over here to go back to myfun.m. If I did just, for some reason, display n, and then go back to the command window and type n equals 1,000,000, myfun of 1 comma 2. I got an error then because it doesn't know what that variable n is. Okay, so this is a very important lesson from a programming point of view. Functions have their own local workspace. The variables that you define inside of a function are invisible to the command window, and the variables you define in the command window are invisible inside of the function. The only exception are the variables that you explicitly pass in and out. Okay, so you pass the values of x and a from the command window into the function, and then they're known inside the function. And you pass this variable fx back out to the command window, and so that value is known. But otherwise, the variables inside the workspace, the function, are invisible to the command window and vice versa. That's the concept of local variables. Okay, we only have about 10 more minutes. Something that's very useful if you're writing MATLAB functions is the idea of default inputs. So let's say that I want to work with this function I've written on the board here. but most of the time A is going to be 1. I'm really interested in A equals 1, but sometimes A might have a different value. I can use this kind of construction to assign a default value. Nargin stands for the number of arguments passed in. If Nargin is less than 2, that means the user did not pass in 2 variables. The user only passed in 1 variable. And in that case, I assign the value 1 to A. So, with that code, I can go out here and type my fun of 2, 1. I can type my fun of 2, and I get exactly the same thing because the default value of the second input is 1. But I could type my fun of 2, 2, and I get a different value because then I'm changing the value of A. All right? So I use that feature quite a bit myself. Similarly, if I type, I don't want to call it A, B equals my fun of 2, 3. Okay, I get the output value. Inside of my fun, that was called fx. That's the output variable, but I don't have to use the same name in the command window. I called it B. Now, suppose that my function is also supposed to compute f prime. Now that's a little bit of a complicated function. I don't know if everyone knows how to compute f prime or not, but it follows from the chain rule and the fundamental theorem of calculus that f prime of x is 2x sine of a times, now I need the square root of x squared. That is the absolute value of x. So there is the derivative. Okay? So I can tell Matlab that I want my function to pass out 2 outputs. And so then my code would compute both of them. All right. Now, in the command window, I can still execute this the same way as before. I only ask Matlab for one of the outputs. But if I choose to, I can ask Matlab for both of the outputs. And then I get the value of f of x and also the value of f prime of x. Lastly, if I want to, for reasons of efficiency, I can only compute the second output if it's actually asked for. So there's a command or a built-in function called nargout, number of arguments out, and only if the user asks for more than one output do I bother to compute the second one. Now in that example, it's really trivial. There's no efficiency gain because this calculation is so blindingly fast. But you can imagine a serious application where maybe it takes, a minute to compute the first output and a minute to compute the second output. And you don't want to be sitting in front of your terminal for an extra minute if it's not necessary. In that case, it would make sense only to compute the second output if it's actually requested. Any questions about how that works? Okay, I think I'd like to show you one last feature of Matlab M files. When I write an M file, I can put in comments. Anything that follows a percent sign is ignored when MATLAB executes the code, but they're useful for documentation. Now, the great thing is the first block of comments in an M file will be displayed when I type help my fun. So I can automatically add help documentation for my M files to the MATLAB documentation system. And you know, again, if you're writing serious code, you might spend 20 hours writing this program, and then 6 months later you want to run it again, and you don't remember how it works. Well, one option is to read the code, but if the code is hundreds of lines, you don't want to go back and read it and figure out how it works. So you can put the documentation here. So you might put in something like this. The first line is special because MATLAB displays it under certain circumstances. So this is a user-defined function from the MATLAB, from the GSG MATLAB seminar. So what I always do then is copy the calling sequence, like that, and then explain it. So this function computes f of x equals the integral of sine of a times square root of t for t equals 0 up to x squared. The output is called fx. If requested, it also computes f prime of x and assigns it to dfx. Okay, so that's the kind of documentation I like to write. I like to remind the user of the calling sequence, and then I make sure I put enough explanation that the user knows what the inputs mean. Okay, well, there's what x means, there's what a means, and knows what the outputs mean. That's what fx means, that's what dfx means. Now, if I go back to the command window and type help my fun, I see all of that information. And so again, if I've written this program and I put a lot of time into it, then I want to use it 6 months later and I've forgotten how it works, all I have to do is type help my fun, and then I see how it works. Yeah, that first line is special because if I type help and then the name of the folder, it gives me a list of all the MATLAB files in the folder. So here's one called My Fun, and it displays just that first line. So if I use the help and then the name, I see all of the text. But if I type help and the name of the folder, I just see that first line summary. Okay, I think we're out of time. I feel like we're a little rushed at the end, but there's a lot to cover. I hope at least I showed you some of the things you can do in MATLAB. If you want a lot more detail, I recommend those 11 videos that I produced for my class a couple of years ago. Look at the very last line of your handout. And if you have any questions, you can always feel free to email me. So I hope it was useful.
Yep.
Thank you.
Thank you.
Yeah.
So, what would you use MATLAB instead of Mathematic or vice versa? Would you use Mathematic instead of Mathematic? It's just preference?
I think MATLAB is easier to use if you're doing numerics, but Mathematica does a much better job of integrating symbolics and numerics. So if you're doing a lot of symbolic calculation, I recommend Mathematica. If you're doing exclusively numeric calculation, my personal preference is for Matlab.
Awesome. Let's go ahead and give Mark a big thank you for taking time out of this week. And thank you all for attending the last academic seminar for this semester. There will be more coming next semester. As one final note, feel free to take food with you because otherwise it just gets thrown out. So feel free to take a snack for yourself, for an office mate, whatever. Early dinner snack. Help yourselves. Thank you for coming.
Quick question for you.
Yeah.
First, thanks. It was very helpful.
Good.
And, you know, I say that as a person who uses it a little bit, but still, it's pretty, you know, needs a lot of help with it. So
Yeah.
we did accomplish that. I was wondering on the function. I should be getting both f of x and df of x. When I call the function, I only come up with one of them.